and the paper and the feces go down in this container. It's not smelling, it's smell nothing. If you don't mix feces with water, it's not smelling. After 1 minute, it's so dry on, so it's not smelling. So once a year, they are taking out the compost. So they alternate with 2 different composts. Yeah, next. And this is the building for waste sorting. Next. And this is the airflow. I use these diagrams just to show the way we are thinking. We are making always the same diagrams for all buildings we are designing, so we can discuss it easy with those who are involved in the project. So the air intake, the supply air intakes come in a tower and in a concrete canal into the building. We have a fan, we have filters, and then the air goes into the basement. So in the winter, we preheat the air by let it go through these buried pipes in the ground. And in the summer, we are cooling down the air by let it go through the earth. And at the same time, when we are lowering the temperature in the air, for the humidity in Sweden in August and September is nearly 100%. So it's very high humidity. So when the air goes down through the earth, the humidity will be lower. And the water from this go back and will be infiltrated here. We have also heat collectors with 800-meter plastic pipings that we can use for preheating the air. Then the air goes into this basement, and then we have drilled holes in the concrete here. And depending on how big the rooms are, we have more or less holes. And the cold, new air flow out on the floor, and they are heated up by the children and goes up with the chimney. So I said when I made this drawing that it's not possible to do that in the summer. But we are happy to say that these metal sheets on the roof is like a sun collector, and it speeds up the air. And so the teachers now told me 2 years ago, they haven't said it to me earlier, it's too cold in the summer. In a wooden building, I can't believe it. But they say we need sweaters on us in the summer inside the building. And we have no AC, nothing like this. And then we understood that we have built something that we didn't know about from the very beginning, that the roof was a part of the ventilation system. So then this was we were very lucky. So let's see, the fittings and all these inside the building, it's very important that the furniture and all what you are made inside the building, the paint and all these things, have low or no emissions. For in the standard for the Swedish building code, we need ventilation at a certain amount for every hour. And half of this is just to take away the emissions in the air. So we can lower the need of ventilation to half if we don't use paint or furniture or all this stuff that have low or no emissions. So this is very important. Yeah, next.
Wait, under there's a little note that says automatic control of CO2.
Yeah.
What is that?
The man in the community, he didn't believe in me. And he said, you are making a school, it will not working. And he said the ventilation will be a disaster. And he said that he make a reservation for a lot of money to put in fans afterwards. I was saying, okay, do that. That's not my pocket. So. But he didn't tell me that he ordered automatic control of the CO2. And now I understand why. After a month or so, when the school was in practice, he thought to call me and said, Anders, I told you it's not working. The ppm of CO2 is above 1,000. It's not working. I told you, but he never called me. And they have never been higher than 800 ppm CO2. And it means that this is the best school in their community and one of the best schools in Sweden with this system of ventilation. There's very, very fresh air inside the building. Yeah.
What happens with the meltwaters or rainwater? How is it collected and where is it stored?
We collect it locally and infiltrate it locally close to the building. Yeah. Yeah. This is the air, fresh air intake. And this concrete, prefabricated concrete, and this canal going into the building. We have made some similar systems in Japan for the office building too. Yeah. And this is the intake, air intake in the classrooms. So if you want to lower the ventilation, you just open this and you switch one of the canals. Stop one of the canals. Yeah. And this is the way we are treating the air for the gymnasium. We have this supply air canal. The air comes in through the floor like this, and we have this natural ventilation in the top of the building. But in the showers, we have forced ventilation, and then we have the greenhouse have also forced ventilation. And this is very interesting. When we had the 10 years anniversary, I was asked to come to the building for this event. And this gymnasium is planned for 30 students. But this event, it was 150 people, I think it perhaps were more than that, sitting in this gymnasium. And I said, what a disaster. The ventilation will not work. So many people, and the canals are so small, and the more people that went into the gymnasium, the better ventilation we got. And this is the same system they have in the Opera House in Paris, built 1880. This ventilation system is driven by the audience coming to the Opera House. So the more people in the building, the better ventilation. So this is really interesting. We have also walls of brick tiles in the showers, standing apart from the wooden structure, so we don't get fungus and mold on the walls. Yeah.
What is it that causes the better ventilation when you have more people? Is it the heat from the people that causes the
Yeah. So every student is 300 watt. BTUs. So if you are freezing at home, invite people. That's the way Diane and Carl have done today. It was a little bit chilly in the morning, so they said, yeah, we invite 70 persons to come here. It will be a little better indoor climate. Yeah, this is the gymnasium. Yeah, next. And this is showing that you could use the same technique for the old building. We have this supply air inlet, and under the corridor we took out and made a canal, and this goes in and serve all the buildings. And then we have a fan that with forced ventilation, and then we take the energy from this air and preheat the incoming air. And also here we have the automatic control of CO2. Let's see if it's, yeah, they have a computer network in the school. Yeah, and this is interesting. The woodwork in the school, the chips from the woodwork is used in the compost for have the cool balance in the compost. And this is also a way to get rid of the flies in the compost. Yeah, next.
When you say control of CO2, is that a monitor?
It's just, they are just picking up the figures for the CO2. It's not, they're not doing anything with the building. No.
Reader.
Yeah, just a reader, yeah.
Can
you open the windows in this thing?
Yeah, yeah.
And nothing happens to
Nothing
the
happens.
cooling system?
No, yeah. If you like to open, it's no problem. Yeah. And this is the old school. Yeah, next. It's interesting. The engineer in the school said, take away all the old windows. They have never been repainted until since they built the house, 1933. And I went out to the site and I took a knife and I scratched on the small pieces of paint that still were on the windows. And they were smelling from the tree. So we can reuse all the windows in the whole school. It's only one window that is new. And this is a commercial project up in Umeå, in the northern part of Sweden. Many years ago I met a man, Mr. Per Karstedt. He has a car dealer and he is very interested in environment. And he has been living in Brazil, so he had been driving ethanol car for many years. And we were on the seminar, and I have never met him before. And he was talking of how we can fuel our cars in the future. I was really interesting, and I was talking of how we can build houses in the future. And we were sitting together at the lunch, and he said that he should start the Ford company up in Umeå, and he wanted to start from zero with a white piece of paper. And he already an architect involved in the project, and he said, no, I understand that we need to have some help from you, just to give us some advice. So are you interested to help us in the end of the consulting phase to check our drawings and specification if we are making a green building? And then I told him that you are, as most of the other clients, you said in the end of this procedure, yeah, green building, that's a must. And then they call me and ask, can we do something in the end of the procedure? And then it ends up with a cellar collector or a toilet like this. And I say, don't do that in that way. So nothing happened until the end of, this was in May, and the end of August they called me and said, I think about what you were saying, and I need to meet you. And after this meeting and the lunch, I went back with an ethanol car, and I was appointed architect and project manager for his project. And then we lived together during 3 years, just like a couple. He was very supporting all these. He was on all the project meetings. And sometimes when we proposed something, he said, I think it's possible to do it better. Go back home, check if there is another technology in the world that can support this project better than what you have proposed. And then we really was in the front line. So this was a really interesting procedure. I learned so much from this project. Yeah, next. So this is the project. It's a commercial project. This is the Ford dealer shop. This is the McDonald's. And this is a petrol station. The 3 worst polluters in the wastewater treatment system in the sewer line in Sweden. And this project has no connection with the local sewer line. We are taking care of all the wastewater by ourselves. We are self-sufficient with energy, so we have no connection to the district heating. We can give energy to 45,000 square feet more if we had enough of buildings in the surroundings. And how can it work? Here's the real energy producer. A McDonald's needs about 500,000 up to 700,000 kilowatt hours per year. So if you have a McDonald's in a block, then you have enough of energy for heating and hot water production for all the buildings in the block. So we are taking the energy from the kitchen, And this is the first McDonald's in the world that have this technique. There are 25,000 McDonald's in the world, and this is the only one that had this system. The payoff time for this investment was less than 1 year. And now McDonald's is not only selling food, or what you call it, they are also selling energy to the car dealer shop. And the fuel station, they have a lot of refrigerators and freezers, for they are selling a lot of food nowadays in Sweden in these buildings. And we take care of the energy from that to feed this building. And then we have bored holes here, for bored holes for cooling and also for the need of energy in the winter. And there is green roofs. So 50% of the stormwater are collected on the roofs, and the evaporation cool the building in the summer. And 50% of the water goes down in this pond, and we are pumping up the water from the pond on 2 places, and there's a stream going all around for cleaning the water, for evaporation, and for infiltration. And that it's rather beautiful to listen to the water when you are in such a place. Most of these car dealer shops, you have seen them here. It's a flat roof with a metal sheet on the outside, and it's asphalt all over the site. Here we have done it in another way, so I will show you some photos of that. And on the top of the buildings we have, this is the only invention we have done in this project, is lantern skylights that gives a very good light inside the building, so we can take away the lighting during daytime. It's not only taking the sun light down, but the light from the sky. And we have developed this together with a company in Stockholm and 3M in London. Yep, we can go through. And this is the car dealer shop. You can see the green roof, the lantern skylights, and we have wind-powered fans for the natural ventilation in the building. And this is the little pond, and we have planted at about 10,000 plants in this pond as a part of the cleaning system for the water. We are using this water for flushing the toilets and for the car wash. And the car wash takes only 15 liters per car wash instead of 300 liters in a normal car wash. So this is also something new. Yep, next. And here's the south-facing facade. There we have a sun collector built of building material that we preheat the air intake in fall, winter, and in spring. We have measured up to 140 centigrades in the end of April when we stop it, and then we are using the air intake through the buried pipes. Next.
You take it, and what happens in the summer with that?
We close it, just close it.
Okay.
Yeah. Mm. This is the McDonald's. It's not looking like the ordinary McDonald's in Sweden. For we said, if you want to be on the train, we tell you how we want the buildings look like outside and the infrastructure. Then you can do what you want inside. But we will tell you no material with emissions. So they were work very close to us. And this is the petrol station at the far left. Yes? This is the inside of the car dealer shop. You see the wood beams and the same roof where we're using this material for cooling in the summer. And here's the lantern skylights. Gives very good light inside the building, so there is no lighting on during the day. And this is the new way we are handling these tropical plants. It's called Levande Filter. It's a Swedish invention. And the air goes down above the flowers, the plants, and there's a fan in the bottom. And the carbon dioxide goes through the plants and it's producing oxygen. But the most interesting thing is this plant are sprayed with water every 30 minutes. And it means that all small dust in the air it stays on the plants. And it's flushed down by the water down in the soil, and it's contaminated in the soil. And we change the soil every 3 years. So if you have cleaned your television screen, have you done this anytime? Yeah. You can see that's a little dust on the surface. And the television screen is negative loaded. And these small things in the air that you can't see, it's smaller than the dust you normally see in the air. It's small, small, tiny things. And there is a lot of heavy metals on this, and they are positive loaded, and they add to the television screen. The human body is negative loaded. So when you breathe in an air where you have a lot of computers or a lot of this equipment, you are breathing all these small dust that you can't see. And it's fastened in your lungs, and it's transported later on out in the grease. So we are polluting ourselves with the indoor air. And that's the reason why we need to make other type of ventilation system in the future. In this building we are also using a new way of making filters. Is Flimmer filter is also a Swedish invention. They have been using this for car factories where they are painting the cars, and they need to have an air without any dust. Otherwise the car can't be so polished as they are. And this is the first building where we have used this Flimmer filter, and now we're using it also in one family houses. And I think for Los Angeles area where you have not so good air all the time, could be an option to install these filters to get better air inside the building.
Sorry. Go ahead. Have you measured those, the effect? Measured it?
Oh yeah. And this on the list you can see where you can find in the list on the in the back page. Yeah.
Hi.
Hi.
I have a question related to the relationship between the size of the space and the amount of plants that you locate inside this room in order to have that, good ratio of fresh air and carbon monoxide circulation.
So for one classroom, you can use one standard shell like this. But we have used this, other people have used it. For example, in the airport of Sundsvall, close to the place where we are living, they have a huge filter with tropical plants. And on one side of the airport building, all the aircraft standing. On the other side is the parking lot. And there's very bad air in such a building. And they are recycling 90% of the air, the indoor air, and give fresh air. And this is a beautiful installation in the airport. Yep, next. And this is in the workshop, and we have also there these standard shells, and you can see the light up here. We have 600 lux in at this level for the cars, so there is no need of electric light during daytime. And this light have the right color temperature, so this is also very important in some cases. So this can be used in shopping center instead of have all these lights on during the day. And most of these Swedish shopping centers has a black flat roof, the best sun collector in the world, and the reason why they need a lot of air conditioning in the buildings. And this in this workshop, the plants are growing very, very fast depending on the carbon dioxide in the air. Yep, next.
Do you use 5,000 Kelvin? Do you use 5,000 Kelvin daylighting color temperature?
Yeah, we can use that, but if you have these skylights, you have the same temperature that it's outside.
So that's daylighting, it's a high,
Yeah.
5,000, 6,000?
Yeah.
Could you talk a little bit about your drain system in a shop where you have contaminants, you know, from the maintenance process
Yeah.
and what's going on when those spill and how they're handled?
Yeah. We are taking care of all this spill from the cars. But they have also another system in this car dealer shop. All the cars which are sold by the company has a special switcher for oil and all these liquids in the car. So when you are going to the workshop, they couple it to a pipe and sew it out from the car, and then they are pumping in the new fluid into the car. So it's no dripping from the car. But we take care of all these. If there are any grease on the floor, we take it apart from the water system. So this is the way we are doing it. And it's also very interesting when you are buying a new car in this shop. You are presented by your own worksman. So when you are calling for repair or for service, you are calling your personal workman here, and he had all these computers, telephone and emails and all this, and he put a price on what you are going to repair, and he bill you, give you the invoice, and he hand over the car. So you have a personal relation to the man who is taking care of your car. And this was one of the parts for designing the building to make it close to those who are buying the cars. Yep, next. And this is one of the ponds. Yep, next. And all over the building we have these small signs telling the story about the building. So when you are sitting on the toilet, you can read what's happening when you are flushing on the toilet. And everywhere about the paint and the idea behind the building, the infrastructure, the installation, everything, all over the building you can find this information. Yep, next. And this is what we have achieved in this building. We can reuse and recycle all the materials inbuilt in the building. And this was very important from the very beginning. It's built for taking down. The reduction of electricity consumption, 60%. Reduction of external input energy for heating, 75%. Reduction of external energy for cooling, 100%. Renewable energy, 100%. It's based on wind power. So